this lesson, we are going to talk about the issues of reliability and validity in the measurements we use in our studies. Let's start with measurement reliability. Reliability has to do with the stability or consistency of a measure. Reliability in measurement means that it is repeatable. In other words, if we are to reuse a particular measure, participants should produce similar scores each time. Take the example of using a bathroom scale as a measure of weight. Being reliable means that we can count on the scale giving us the same reading each time we step on it, unless of course we've gained or lost a lot of weight since the last time we stepped on it. If the scale gave us a different reading each day that we stepped on it, and we knew it wasn't because our weight had changed, then we would say that the scale as a measure had low reliability. So, how do we determine whether or not a measure is a reliable one? There are a number of ways to measure the degree of the reliability of a measure. We'll talk about a few of the more common. Let's start with test-retest reliability. With test-retest, we can determine the degree to which the same test score would be obtained on another occasion. Participants are given the same test or measure at two different times, and the correlation of the two sets of results is determined. So again with the bathroom scale, we could take a measurement one day and then again the next day, and the correlation between the two scores would give us an indication of how reliable that measure is. Next we have inter-rater reliability. In research that involves multiple raters making judgments or observations, especially with observational research, it is a good idea to run correlations on their sets of ratings to make sure there is high agreement. The next two methods of determining reliability specifically examine something referred to as internal consistency. Internal consistency determines the reliability of items within a measure with each other, which is especially important if all items within a measure are intended to get at the same thing. One measure of internal consistency is split half reliability. If you have a measure that can be split into two homogeneous halves, such as a questionnaire, then rather than repeating the whole measure as with test-retest reliability, you can correlate the results of one half with those from the second half. Sometimes the traits or behaviors that you are trying to measure are not stable over time, so split half reliability has an advantage over test-retest in that you are comparing sets of scores from the same point in time. And finally, we have item total reliability. The item total reliability method finds the average correlation of each item of a measure with the total score. And now on to measurement validity. The concept of validity was discussed in a previous lesson. Here, we are focusing specifically on validity with respect to measurement. A measure that is valid is one that measures what it is intended to measure. So, for example, if we give participants a questionnaire for a study of self-esteem, then we want to be sure that the questionnaire is indeed capturing self-esteem and not some other construct, such as extroversion. The degree to which a questionnaire intended to capture self-esteem actually measures self-esteem indicates its level of validity. As with the validity of other aspects of a research study, there are many types of measurement validity that can be considered. We will review a handful of these here. Let's start with face validity. A measure with face validity is one that superficially appears to test what it is supposed to. If, on the face of it, it appears to be a reasonable measure, then it is considered to have high face validity. One way to determine the level of face validity of a measure is to ask a number of experts to rate the measure. Take, for example, a study of math ability that uses a test that requires a participant to complete math problems. A measure such as this would have high face validity since it is a reasonably safe assumption that completing math problems will get at the construct of math ability. However, using the same math test as a measure of, say, shoe size would yield pretty low face validity. Next we have construct validity. When setting up a study to measure a more abstract concept, we need to create an operational definition that allows us to measure the concept. Construct validity determines the degree to which we believe the operational measure actually assesses our original construct, and not theoretically unrelated constructs. Take the example used earlier of a questionnaire used to measure self-esteem. If the questionnaire contains items that ask primarily about being outgoing and extremely social, then it may be a better measure of extroversion, a related yet different construct from self-esteem. In this case, the questionnaire would have low construct validity as a measure of self-esteem. Next we have content validity. Here, we are concerned about the degree to which a measure assesses all dimensions of a construct. For example, say we want to operationally define the construct of athleticism. Using a measurement of the number of points a participant scores during a basketball game may not have very high content validity because it is possible that a person is very athletic in certain areas of exercise beyond basketball. A measure of athleticism with better content validity would be one that covers all or at least most areas of athleticism. One way to do this would be to simply ask participants to report on the number of times they engage in athletic activity each week. Criterion validity. Criterion validity tells us how well the results of our measure correlate with those of another measure for a related construct. For example, the measure of IQ is related to how well children do at school. Therefore, IQ scores should correlate well with measures of academic performance, such as grades in school. Related to criterion validity is predictive validity. Predictive validity tells us the degree to which a measure is able to predict performance in the future. Criterion validity and predictive validity go hand in hand in that in order for one to measure or predict future performance on another, the first has to have high criterion validity for the other. And finally, we get to discriminant validity. Discriminant validity tells us the degree to which the results of a measure do not correlate with those of another when the two are representing distinct constructs. We just talked about how sometimes we want measures of two constructs to correlate with each other, but sometimes we may want one measure to be distinct from another. After all, a measure is no use if it relates to everything. For example, we may want to be able to distinguish appetite when somebody is in the mood to eat from true hunger when someone's body is in need of food. In this case, a measure of appetite has discriminant validity if it is able to distinguish appetite from hunger. So, we have talked about both reliability and validity of measurement. One last point to make is that both of these are important when determining which measures we plan to use in our research. A measure that has high reliability but low validity is of no use to us. For example, a bathroom scale may have high reliability in that it gives us the same measurement each time we use it, but it has very low validity as a measure of foot size. Likewise, a measure that has high validity but low reliability is equally problematic. Perhaps we do use a bathroom scale as a measure of our body weight, but if the scale gives us a different measure from day to day, it won't be any use to us. We need to be mindful of both measurement reliability and validity in our research.